Okay, power law of logs. So we've talked about log functions and how they relate to exponential functions, and I'm just going to quickly write this on top. Our log function, so say we have log base 10 x equals y. Okay, the base is still the base in our exponential function. Okay, this y becomes the exponent, and this value goes on the other side of equal sign, becomes what it's equal to. Now, when we have a power of a log, so we're putting something up, let's call it, maybe, we'll rewrite another rule here. Same idea, log base 10 x to the power of, let's say, 2 equals y. Okay, what we do here, in this case, is this 2 actually comes to the front of the equation. Okay, so it then becomes multiplied by 2. So really we can rewrite this as 2 multiplied by everything we had before. Where we can still write it as log base 10 x, well, is technically equal to y. So we can evaluate this, okay? And we already know to evaluate this log base 10, we just put it into an exponential form, and whatever it's going to be equal to, that x, we can plug in for this. So it looks a little confusing right now, but let's actually do the steps we're talking about. We're going to take this 3, and we're going to bring it to the front of the equation here. So we get 3 is equal to log base 2 to 32. Well, let's actually just evaluate this, because really this means just 3 times that. I can change this log into an exponential function, right? This becomes multiplied by, and I guess we'll do it in blue here. This becomes our base, so our base is now 2 to the power of x, which is our unknown, is 32. So I know it looks a little weird. What we're going to focus on is just solving for x. And when we solve for x, that is what this is essentially equal to. That's our x. It's kind of in there, okay? Now mathematically this is being written a little odd. What we would usually do is do this type of calculation on the side and then just replace this in here. But we're going to keep it in there so we have that idea. We're solving for x. So in order to solve for x, 2 to the power of what is going to give us our 32?
5.
That's right. So in other words, this here is really just equal to 5. So now in this question, it just becomes 3 times 5, which is 15. Very simple idea. Let's try another one. I don't want to steal too many. Well, maybe we can make one up. Log 5 225 to the power of 4. Okay? I think this should work. So, same idea. We want to bring our power of 4 to the front of our equation. So we're going to get this equation is equal to 4 multiplied by our log base 5. So we'll write this one mathematically correct this time. Okay. Well, this is where we would do our side calculation. I know that log base 5 of 125 can be written as an exponent of 5, okay, and this is x. That x is what we're going to replace this with. Well, this x becomes our power of 125. X, or 5 to the power of what will give us 125? Exactly. We know x is equal to 3. So in other words, we can replace what's within these brackets with just the number 3. That's what that is equal to. So our question now becomes really 4 times 3, which is just 12. Okay. It's a very easy idea. As long as we remember the original log rules, we can get by with power logs, no problem. We just bring it to the front.